The purpose of today's lesson is to show representations of linear context. Now the difference here is context is really a story or a word story problem, I guess is what we call it. So let's take a look. Courtney is collecting coins. She has 2 coins in her collection to start with and plans to add 4 coins each week. I'll always note whenever they talk about something each week, per day, per minute, and that is important because that tells me that's my rate of change right there. That's my rate of change anytime they talk about per or each. Okay, we're going to complete the table and graph to show how many coins Courtney will have after 6 weeks. At 0, she started with 2, so we would do 2. After 1 week, she's going to have how many? Well, she's going to get 4 more after that first week, and she already had 2, so it's going to be 6. And then after 2 weeks, she's going to get another 4, so that's going to give us 10. So we know what the rate of change is. This is our difference column, and each time it's going to be 4. So I could just go on down and just keep adding 4. That seems easier to me. And after 6 weeks, she's going to have 26. All right, and then we have to complete the graph. All right, well, we have to label it ourselves. But we know this is always going to be the x, and this is the y. So over here, we have to do the number of coins. This is our coin side, and here is the time, and we have to designate weeks, because if we just said time, we could be talking about minutes, months, days, whatever. All right, and we have to strategize with our numbers. Sometimes it's not going to be this easy. Oh boy, see, I have to get up to 26. If I go by 2s, I don't think I'm going to have enough. So, let's see, 2, 4, 6, 8, 10, yeah, that's not going to be enough. So I may have to go here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then 24, 26, 28. So you may have to strategize when you're figuring out your table. Okay, let's go ahead and plot our points. At 0, we're 2, and then we go, I'm just going to go up 4, 4 over 1, up 4 over 1, because, yeah, up 4 over 1, that's easier than trying to match these up. It's fine. Yeah, there we go. Okay, and then, of course, we could connect these. So keep in mind the rate of change is 4, because now we're going to write our equation. Number of coins C, Courtney will have after W weeks. So C is going to equal something W plus or minus something. Okay, remember we talked in the previous video? The number that is in front of this variable right here is our rate of change. Rate of change. And what is that? Well, that's 4. And what do we say this number is? That's always the y-intercept. So we could go right to the graph and we see what the y-intercept is. Oh my gosh, it's right there. It's plus 2. And it was right there in front of us. And notice on the table, what number matches with 0 is 2. So this is also the y-intercept, because the y-intercept is when x equals 0. That's another piece that is helpful. Okay. Is this context linear? Use evidence. All right. Well, sure it is. Let's go ahead and do. Yes, because our graph, it's a line. That's what we're looking for. The context, that's our story, is she adds 4 each week. Remember I talked about that? Each week, per something. Those are important. It's a constant rate of change. the table. What does that give us? It's the constant difference is 4. Constant difference is 4. These are all evidence of that it is a linear equation. And then our equation, of course, can be written, and this is something new, y equals mx plus b. What do you think that m represents? What's the m? Well, it's the number in front of x, and that's our rate of change. And what is this? And that's our y-intercept every single time. This is also known as the slope. It's also called the slope. Alright, this next problem, number 2, I'm going to let you do on your own because it's very similar to problem 1. So 2 on your own. And I'm going to do number 3 with you. Alright, so let's scroll through there. There's some extra questions, but you can figure that out. Here's our number 3. An airplane is at an elevation of 3,000 feet. The table below shows its elevation y for every 2 miles it travels. Okay, so I'm looking at this and I'm saying, ooh, this looks constant, and this is going down by, notice it's going down by 1,000. Okay, 1,000. Oh, but notice this. This is going up by 2. Oh. That's going to take a little thinking then, isn't it? Because when we do our unit rate, we want it by 1. Well, another way to think of this is we could take negative 1,000 over 2, and that's going to show us that our rate of change is a negative 500. Okay, and now we get to graph this. So we have to strategize with our graphing to show this side is our elevation, of course. Elevation. I'm going to write all that out. And then this side is the number of miles. Oh boy. I accidentally clicked a little button on the pen. Be careful with that. This is our miles. And this is pretty consistent. This is just going up by 1, but here we need to get up to 3,000. So what might be good numbers to go up by? Well, we have 1, 2, 3, 4, 5, 6. So 3,000 divided by 6, that gives us 500. So we could go up by 500. 1,000. Let's go jump up here to 2,000 and then 3,000. So go ahead and plot those points on here. Alright, did you get the same thing? So let's connect these. And what does this even tell us? Well, this is elevation here, and at 0 elevation. So that means it's reaching the ground. What does that even tell us? That means 6 miles to reach the ground. So use the table and graph to find the rate of change. Well, like I already did that. The rate of change I already did is negative 1,000 over 2, which gave us negative 500. Well, what does that mean? That means it's descending at 500 feet per mile. 500 feet per mile. So every mile it's going down 500 feet. Write an equation. Okay, we got this. We're going to use y and m. If they don't give us variables, then, or did they give us variables? Yes, they did. My bad. Yes, they gave us y and x. So we have something x, and then this is when this is the y-intercept. So what is the rate of change? What is the rate of change? Well, we decided it was negative 500. So we put that in for our slope, and what is the point on the graph where it hits the y-axis, and that is at a positive 300. Kidding, 3,000. Explain how the equation can be used. Well, the ground would be an elevation of 0, so if you plug 0 into your equation for y and solve for x, you will get 6 miles. So you can use that equation to determine when it's going to reach, or how long before, number of miles before it reaches the ground. Alright, this concludes our lesson on representations of a linear context.